So this is Open Networks, Technologies and Policies for Consumer Choice and Innovation. And this is actually this whole theme is one of the reasons that we've been, working for more open airwaves, because one of the things that open airwaves does is it allows consumers much more and innovators much more choice in terms of different wireless networks, allows more competition, and thus limits the ability of the certain commercial carriers to keep people within walled gardens and violate net neutrality. So we're hoping that with much more choice and open networks, that this whole openness, the whole net neutrality thing won't be an issue. But there's, it's a big issue in and of itself anyway, open networks, open technology. So to begin is Sasha Meinrath, my colleague, who is director of the research director of the Wireless Future Program at New America. He's also a globally known expert on community wireless networking, and it actually built really hands-on, grounds-up the first open source community wireless mesh network at Champaign-Urbana before he came to New America. Among other things, you can read on the bio sheet. Sasha.
Thanks, Michael. So I thought, I spent a lot of my time in the Beltway battling with FCC, educating FCC congressional staffers, having great conversations, doing a lot of wonking geekery, and sort of diving down deep into the technologies. But I also spend a good amount of time with community activists and organizers and folks working on the ground in the open source community. And so instead of geeking out with you all today, I thought I would sort of pull back a bunch and give sort of a 30,000-foot view of why all of this matters to those of us working on the ground to better society. So what are the social economic justice aspects of what we're doing here? And fundamentally, it's important to keep in mind that there's an epic battle being waged right now in D.C. that affects not just the entire country, but will reverberate internationally and affect the very future of communications. And one of the notions at play here, one of these potential issues, is what the future of communications will look like. Will it be the notion of the single, isolated end user connected to the web, downloading the content of her choice, or will it be more of a local network, an interconnected network? Will it be an interconnected web of users, a participatory community of media producers and information dissemination? And at the heart of this battle are two warring factions. Those that want to push for closed networks, these proprietary, expensive, relatively limited, fractured communities. When you always hear people talking about market share and take rates and proprietary and expensive build-outs, these are code for I want to build a network that gives me control over my users, which contrasts with this notion of open networks and the strengths of open networks. And these open networks are often cheaper to build, cheaper to implement, and effectively designed for interoperability and extensibility, and are not often what we see being deployed in the United States and around the globe. So one of the most important elements of these open networks, something that's just beginning to be discovered in a lot of ways, is that you can put services and applications onto the local network, often for free, but which are directly meeting the needs of the participants in these networks, that are meeting sort of the service and application desires of participants in this network, and that allow end users to utilize the devices of their choice on these open networks. And so you have the Open MoCo. We are here in Googleplex, so you also have the G phone. Technologies that allow people to use the hardware of their choice on whatever platform, however conceived, however functional or not, that's available in their local communities, like the one laptop per child. So really what this comes down to is ensuring that technological innovation continues at the edges of these networks, even though the importance of network connectivity is on the incline. In fact, it's becoming more and more important what you can do on the networks. we don't want to end up with networks then controlling what you can do at all these different levels of these communication systems. And within the free and open source software community, a place that I've inhabited now for the last 8-9 years, these networking technologies have matured to the point where they can do often the same things and often more than what these proprietary closed systems make possible. And so for the past 8 years, I've been working on sort of the Open Trifecta, what did I call it, which is to help build next generation communications, wireless communication systems, where the potential for disruption of these systems is only beginning to be realized. And so for a moment, bear with me, I'll dive a little bit into one facet of the Open Trifecta, in particular dealing with community wireless networking, which in the spaces that I've inhabited has been both open source and open protocol, as well as open architecture and open spectrum. This is what people are talking about today in various and sundry ways. What's really important here is that inside the Beltway, in DC, we've really only focused on the last two of these areas. You know, network neutrality is fundamentally about open architecture and preventing sort of the worst egregious excesses of corporations that want to control what you can and cannot do with what they perceive of as their networks. When we look at open spectrum, whether it's dynamic spectrum access, wireless in terms of 802.11 stuff in 2.4 or 5 gigahertz range, and now whitespace devices, fundamentally this comes down to the public interest groups going to the FCC and to Congress and saying, we need this medium of communications in order to build systems that support social and economic justice in our communities. And what's been missing has been this translation service, if you will, between the geeks and the wonks, to allow us to actually translate what we know to be fact. We look back there, we see a dynamic spectrum access device working today, yet we fail often in our ability to make that knowledge and that reality known to the people making decisions about the very future of telecommunications. So the foundation for this critical battle, the heart of this critical battle, is a future over communications that comes down to a single simple question, which is what will the future of connectivity be? And there's two options here. It's really very simple. The next few years will decide what the next several generations of telecommunications look like. And on the one hand, you have a command and control infrastructure, which is centralized, expensive, proprietary, and exclusive. You will never have universal access and affordable access using these models. And on the other hand are open interoperability, participatory networks, the sorts of networks that are possible if we continue to push innovation to the edges and support this open trifecta at every level, at the engineers all the way up through to the FCC commissioners. So there's sort of a part two to this that I'll give on the next panel, which is what this all means on the ground today. But I'll leave it there, and here's where you can get a little bit more information. Thanks.
All right, thanks, Sasha. Next, we'll have Tim Wu, who is a professor of law at Columbia, chairman of the media reform group Free Press, who we work with quite a bit, and I can announce today a fellow at the New America Foundation.
Oh, good.
Starting, welcome, starting shortly.
Good, I'm glad to hear it. Just give me a second while I... Oh, here we go. Oh, I'm using the web instead of PowerPoint. That's a new innovation. So,
Can we get these materials? Speaking of open, are they?
the World Wide Web, I think, pretty open.
Will be on newamerica.net. The event will be featured on the homepage, and they'll all be there, along with video, if you know anyone who wants to watch this again.
So I had this all on my computer, but so I'm going to take the time today to return to a favorite topic of mine, a pet topic, the structure of the wireless industry, the business structure of it. And it's a chance for me to go back. What I'm going to do today is go back to a paper I wrote 2 years ago and published last year with New America Foundation, this paper here, which was originally called Wireless Net Neutrality, Cellular Carter Phone and Consumer Choice. Since then, I changed the name to Wireless Carter Phone. And this was a paper that was the idea, actually myself and Michael and Jim Schneider, who was then at New America Foundation, to kind of just figure out what, at the time, to give you the background, we were interested in, and everyone was talking about net neutrality. Everyone still is talking about net neutrality. And I was always sort of interested in, well, what's going on in the wireless markets? How does this story look? To what degree can you attach whatever devices you want in the wireless market? To what degree can you use the applications of your choice, or what degree is there blocking of certain applications? And what is the application development environment like? So I spent about a year and talked to tons of people in the wireless industry, everyone who would talk to me. Most of them, many were afraid of retaliation, so many were anonymous, and developed the following picture. And what I'm going to do today is talk a little bit about what I saw back then, and then talk about some of the things that have changed over the last year and a half, mostly for the better, I'm happy to say. So in that study, in that paper, we were interested in the four things we became interested in were the problems of network attachments fundamentally. The network attachments, fancy word for can you use whatever phone you want. People are used to, in the regular computer world, they're used to the idea, if you have a Comcast connection, you don't have to have a Comcast computer, right? No one's ever heard of a Comcast branded computer, otherwise you can't use it. This has been a fact of life since the 80s for the phone lines, and the 70s and 80s because of what are called the Carter phone rules, the plug-and-play rules for attachments. And this we found very much not to be the case in the wireless world, and still is quite we'll talk about how that's changed. The second thing was this problem of feature crippling, blocking Wi-Fi and Bluetooth and all sorts of stuff. The third was discriminatory and broadband plans, and also misleading advertising in the broadband world. And the fourth thing was this general problem of application development. Everyone we talked to, the quote I think I got somewhere there, that it's just a tar pit, that it's very difficult to develop applications in the wireless sector, and this is what people complained about. Now, not all of this I at the time said was necessarily something the government could or should solve, but these were certainly things that I thought were problems with the industry and might be better. And so let's talk a little bit about what happened. I want to just pick up one diagram here. And I'll also open another thing. Now, in some ways, PowerPoint's a pretty good application. So if you look at this diagram here, I think this diagram is a very important diagram to understand this industry. Which is to say, this industry, the wireless industry, is a classic platform-based industry, a classic triple-layer industry, where on the top you have a whole bunch of different applications. These numbers are now old, but at the time, voice, music, messaging, pure data were the main sources of revenue, and these were the main apps in this world. You then have basically a four-player oligopoly, which has over time become more and more. I mean, there still are four players. Some are obviously stronger and weaker than others. AT&T, Verizon, the strongest, and they kind of, as the diagram suggests, they're in a good position to control the industry based on where they are. Everything has got to go through them because they've got the spectrum, and also they control retail. And then on the bottom you have what kind of consumer equipment is available, which at the time was even less. This is before. We wrote this about the time the iPhone was coming out, so this was even more limited. Simple phones, smartphones, future equipment. And the way this industry was, and to most part still is that central layer is used to control what happens above and what happens below, to some degree. And this is actually a very common pattern in the media industries and the information industries, that you could replace that with Windows and understand why there was an antitrust lawsuit. I'm doing research now in the 1920s in Paramount Pictures, controlling distribution of films, very similar. It's a very common kind of thing that happens. There's a big debate over whether it's good, whether government shouldn't get involved or not in these things, but it's certainly true that when you have actors that have that much control over what goes on in this market, the potential for abuse is serious. So let's check out a few of the things that happened. Let me start now with, this is sort of more on the direct effects. So after that paper came out, Skype filed a petition, and we're going to talk a little bit about that, asking for a wireless Carter phone rule. That is, they filed a petition asking the FCC to set a rule allowing any consumer to attach any device to the network. And that was the first kind of action on this thing. The next thing we saw, which a lot of you will know about, is you had the C block. Kevin Martin issued the rules, which will. This might or may not be the right thing, but the C block. Everyone here presumably knows about the auction. The whole C. What followed this paper and the sort of buzz around these issues was the C block auction, which was ultimately won by Verizon. And so what we with Verizon being required to follow the rules. So in other words, since the time of that paper, we have seen or will see an instantiation of the wireless Carter phone rules. That is to say, on Verizon's, at least on the C block, they are required legally to have open devices, or allow anyone to attach any device they want. What that actually means, we don't know yet, but we'll see. The other thing that Verizon did is Verizon announced that it was switching sides, effectively. Let's see if we... Yeah, that's right. So the other thing that in November is that, well, here's the whole thing, is Verizon made the announcement that it will, there it is, any device in any application. Verizon actually, I had singled out Verizon at the time as being the worst of all of the players in this field, and they kind of suddenly became very, very open to these ideas. The Open Development Initiative, and I'm happy about that, and there you go. So they decided, you know what, we want gas pumps to hook up the internet too. Or we want gas pumps to be able to hook up to our wireless networks or something like that. So anyway, so Verizon kind of switched sides in this, and this was or at least said they are. We don't absolutely know what that will mean in practice, but all the right phrases are being said. The other thing that Verizon did, actually most of this is about Verizon. Verizon then also decided. Verizon also decided here somewhere that they. One of the things we actually pointed out in that paper was that Verizon was advertising their stuff in a misleading way. They were advertising their wireless data program as unlimited, when in fact, A, it was limited, and B, you couldn't use it for a whole bunch of stuff. You weren't allowed to use it for iTunes Store or things like that. There was a whole bunch of contractual limits and also just bandwidth limits. And so Andrew Cuomo and his internet office went after them, and they agreed to settle it and give some money to New York. So that changed. So that's basically most of what happened. I'm trying to think of anything else happened. The big shift, I guess, is we have started to see the first wireless Carter phone rules. They're not, some set by Kevin Martin through the auction process, and some voluntarily adopted by Verizon. So that, I think those were big shifts in the environment since I published the paper. Let's see what else happened. On the application front, I had said in that paper that there was that basically the application environment in the wireless world was more or less a disaster. That's what a lot of people told me. They said, we're excited, we have a new startup. It's just really hard to do any application development in this space. The carriers want to know how they're going to make more money every time you propose something, and maybe you have like a social networking idea or something, and you're not 100% clear how this is going to make a lot of money for Verizon or AT&T. So they're like, well, we're not interested in this application. Or there was a lot of problems with having a platform to write to that was uniform. There's a lot of fighting over what that should be. Basically, most people felt it was a mess. Since that time, a lot has happened. First of all, everyone knows this is in this industry. You now have the iPhone App Store, which I don't have to say that much about, but obviously there's a lot more room for people to program directly to the iPhone using this and sell directly to customers. And so Apple has played a very important role in having a bad website. No, let's see. Applications, there you go. There we are. So applications unlike anything you've seen on a phone before. So Apple has played a really important role in all of this, but in opening up and creating an application environment that is, to some degree, open. It's not perfectly open, but it's certainly more open than anything we saw before. You still need to be an approved Apple developer in order to do this. It still is Apple's proprietary platform that you're programming to, but it's certainly a lot better than anything that was going on before. However, Apple may obviously soon be upstaged by our friends in this very building, Android, which of course is which we may hear more about. Android has released, I think recently, in the last couple of days, released their source code. And so in the Android environment, well, here's something good enough. Oh, no, that's not good enough. Let's see this. So here is the, I don't know if this is this. Anyway, all of you know what Android is. Android has, within the last couple of days, if I'm not mistaken, released their source code absolutely to the public. So Android is on its way to being by far the most open platform for wireless development, and a very interesting platform. So that has changed a lot. There's been a huge amount of change, in other words, in this application area, and all very sort of positive change. So for the most part, after written that paper a year and a half later, I guess pretty happy. I know I'm supposed to complain, but actually things have gone in a generally positive direction with some exceptions. Now let me talk about what some of the challenges are or the questions are remaining. So one question is to what degree this power that that we've seen here, the power over where's my wherever that was, the power that the carriers still have will be asserted or not. Android, as it launches, is only launching with T-Mobile in this country. And the question is whether AT&T and Verizon will use their considerable power to try and maintain a chokehold over the ability of Android to take its model of open development to the entire wireless world. That's a really interesting question. To some degree, it'll test the degree to which Verizon or AT&T, on the one hand, the Android model is a threat to their culture and their traditional way of doing their culture, their way of making money traditionally. On the other hand, at some point, if everyone wants an Android phone, are they really going to stand in the way? The other thing that Google can do, and surely is doing, is to try and outflank these companies to the degree they're resisting Android by going to huge carriers in other countries like China. America is no longer the it for the consumer base in electronic products. And if there are hundreds of millions of Android users in China, that can create a gravitational or hydraulic pressure on American standards. I think we may be past a day where, in the old days, America set all the standards, and that's starting to change. The final question is, to what degree the sort of classic net neutrality rules, and this is the question I predict we're going to face this question the next year. To what degree the classic net neutrality rules, as in you can't block, you can't discriminate too much, will be applied by an FCC to a mobile platform. So, for example, if AT&T decides to block Hulu, just decides for whatever reason, it may own Hulu, I don't really remember, but let's say they just don't like Hulu on the wireless platform. They don't want their users trying to use it, so they block it because it uses too much bandwidth. To what degree will the FCC think it has the authority or not have the authority to oversee that and maybe prevent that from happening? That's the open question. That's an open question. And I think it's something that they're at the FCC. In fact, I know it's something they're thinking about right now. And with that, I'll leave it there. Overall, an optimistic picture with some possible clouds on the horizon.
All right. Thanks, Tim. That was one of the best web-based PowerPoints on the fly I've seen. So thanks for preparing. But you were definitely spot on, and that last. I should have waited till after to announce, right? But that last thing you mentioned, that's right. I think that's what the public interest groups and others have been laying a lot of groundwork, but waiting. Hopefully, we'll see an even better FCC next year to address that penultimate question, in a sense, of whether not only Carter phone but non-discrimination rules will be extended from the wireline to the wireless space next year. And for more on Google, Larry Alder is the final speaker in this troika. And Larry's a product manager here at Google who is a lead engineer on the wireless team and is responsible for Google's municipal Wi-Fi network over Mountain View here, which was a great prototype. And if you have any complaints, if you're having trouble getting online, just call Larry.
And started a new slide here instead of showing the show.
So we'll hear a bit about Google's wireless vision, hopefully. Thank you.
Thanks, Michael. Again, my name's Larry Alder. I am a product manager here at Google, and I've been here a little over 3 years. Initially came to Google to work on this municipal Wi-Fi project, and we've done a lot since then. So the title of my talk is Effective Use of Spectrum today. So the first question is always, why is Google involved in spectrum and wireless access? And we got to start with our mission statement. And if you don't know Google's mission statement, it's to make the world's information, to organize it, but also to make it universally accessible. So my job really falls in the universally accessible part of our mission statement. And what we've done at Google is we've formed a team, we call ourselves the Alternative Access Team, that looks at this idea of universal accessibility. Let's face it, at Google, we've got a lot of engineers. Most of them are developing applications and web services. Not a lot of them are looking at how does our customer actually reach those web services. So the Alternative Access Team is really trying to ensure that there's a good access platform, that it's open and it's robust and it's available for our users to reach our services. And we've kind of divided into 3 big goals here. The first one is we just want more and bigger broadband pipes. Motherhood and apple pie, but that's the main thing. We think there's work to be done to get more and bigger broadband pipes. We want to preserve the openness of the wireline internet. We think the wireline internet, it's reasonably open. As Tim said, you can go to the store, pick out the PC of your choice, bring it home, connect it to the network of your choice, and use the application of your choice on the wireline service. And then what we want to do is bring what we call that open ethos of the wireline service to the wireless world. And as Tim said, the wireless world just isn't as open. It's much more difficult to buy the device of your choice, use the application of your choice, and all those things. So those are the 3 big areas. So why is spectrum important? Because I'm going to talk about spectrum. Well, wireless, everyone is accessing the internet more and more over wireless. Increasingly, whether it's a local area connection or a wide area connection. So as Google, it's important if people are accessing information wirelessly, we need to understand spectrum. Also, the wired and the wireless are starting to work together. Most people, like in this room, you've got your laptop, you're getting a very rich internet experience. And if you look at the iPhone and applications that have Wi-Fi built in, what we see at Google is when people are at home and they've got a very quick connection when you're very close to the wire. It may be a wireless connection, but because it's near a wire, it's very fast, it's very cheap, and people do a lot more. They do a lot more searches. It's good for Google's business. We just see a much greater usage of bandwidth when it's near a wire and it's a fast connection. So we want to see better wireless and wired work together. It makes no sense to have your phone at home when you've got a Wi-Fi connection talking to a tower that's several kilometers away that's heavily loaded. And we want to see a balance of licensed and unlicensed spectrum. And we really want to just see a lot of openness and innovation. So what are our concerns? Our first concern, I'm just going to run through this pretty quick, is the spectrum is not fully utilized. We've heard that today. There's a lot of fallow spectrum. It's wasted in time, space, frequency. We've heard that today too. The one thing we haven't heard, we touched on, is the licensed spectrum is becoming increasingly consolidated. And what we're seeing is all these licenses, if you look in the recent auction, there was 2 major purchasers of all this spectrum, AT&T and Verizon. As things consolidate, we all know what happened. Tim has written a great paper comparing network access to the oil industry and talking about when consolidation happens, what the effects are on pricing and access to that resource. And bandwidth is similar. It's the resource of the information economy, as Tim would say. And if that resource is controlled by just a few players, that's a dangerous situation. And we really want to do that, avoid that. And that's why spectrum is very important, to not have it totally consolidated in just a few hands. And because of that consolidation, innovation is currently constrained. We'd like to see more innovation, believe there should be a lot more innovation there. And then there's a severe lack of unlicensed spectrum below 1 gigahertz. So those are our concerns. So the first thing is, what about unlicensed? What can be done? So we did an experiment here in Mountain View, and that's a map of Mountain View, where we rolled out a free Wi-Fi service to cover the whole city. We didn't focus on hot zones. We tried to cover the whole city and see where people will use it instead of trying to predict where people would use it and put the stuff there. The map you see there is a picture of where the access points are and how much they're being used at a certain instant in time. The darker red they are, the more data is flowing through that access point. And you can see that the city is widely used. Most of the time, there's people using this network here in Mountain View. And the interesting thing is kind of down that lower corner at the bottom, that's the more affluent area of Mountain View. That's where I used to say $1 million homes are. Well, it was $2 million. Now they're worth $1.5 million. But that is the least used part of the network. And the rest of the city, the darkest part is downtown. And then the rest of the city has a mixture of types of people living in it. So what we did see is the usage. The usage has continually grown. The bottom figure is the one to look at. The green is kind of the downlink traffic over time. And we just see every day there's more and more traffic on this network, and we just keep loading it. So the key lesson is there is a demand. Even in a place like Mountain View, where there is plenty of DSL, there's plenty of cable modem, there's good broadband, if you put out a wireless broadband that's free, admittedly it's free in Mountain View, you're going to see people use it. There's still some challenges. There's challenges with the current Wi-Fi ban. Quality is still an issue. I know we have some of our friends here who work in the industry, but the reality is quality is still an issue. For a free user, they're willing to put up with it. But the paid usage model just haven't worked yet. The quality is just not there to compete with the alternatives. But the innovation is there, and it is possible. And I think one of the things we're talking about is what would people do with this pervasive connectivity? And one of my favorite slides is, here's what someone's doing with pervasive connectivity here in Mountain View. They've hooked up a big screen television in their minivan, or their SUV, and they're playing Xbox and gaming as they drive around the city. So that just shows you what might happen. So that was our initial experiment. I think what we've learned there, as I said, demand is there. So what else is Google doing in Spectrum? There's really 2 things. And the first is we're promoting openness. This wireless Carter phone, very simply, any device, any application, no blocking, no locking. That's been our goal. We participated very heavily in the 700 megahertz C block, the rulemaking, and the auction itself. And we're looking forward to Verizon launching a very open network on that spectrum. We're also promoting efficient spectrum utilization in the TV Whitespaces as an example. But those are the 2 things that Google's really trying to do. Get more spectrum utilized, promote openness, any device, any application. I'm going to shoot through this because we've heard a lot of this. The TV Whitespace, we think this is a big opportunity to improve the efficiency of spectrum utilization. There's over 200 megahertz there. It's the unused spectrum that when you turn your TV to it right now, you get this screen with the white stars. That's where the white space is. And the reason it's important is it's really the missing piece of the unlicensed world. We've got unlicensed spectrum at 2.4 and 5.8, but we got really nothing below a gigahertz. So we're very much limited in how we can innovate and the types of services that can be deployed. They're constrained by just this high frequency spectrum. So we need to see this happen. And it will allow the different characteristics of the different bands to be very complementary. And the spectrum's global. So people can eventually have a global market for devices in this. So it's very important. And what's Google's position? So there's 2 critical elements of the ruling that Google wants to see. We want to see unlicensed operation in this band. There's been arguments we should make it licensed. I think Michael did a good job talking through those arguments. So Google's a big proponent here of making it unlicensed. And we also want to make it available for personal portable. There's been some talk of it should be fixed only. I think we're largely past that. The Commission has realized that the value, if you don't have personal portable devices, the market just won't be there, the economies of scale won't be there. And so Google's been fairly active in this. Larry Page, it's a personal passion of his as well. He's visited DC several times and spoke on it. We've joined the Whitespaces Coalition with our traditional competitor, Microsoft. Bill Gates was talking to the Commission trying to support this yesterday, so it's one area that these two companies can work together on. We're a member of the Wireless Innovation Alliance, and we've launched something called freetheairwaves.com, where you can get some videos that describe this initiative. So what's going to happen in this ban? And this is where I dispel the rumors. Google must have some kind of master plan to use this ban. And this is a slide I've used before talking to people. The first thing to understand is Google isn't asking for a license. The broadcasters go, oh, Google's trying to get free and cheap spectrum here. We're asking for the spectrum to be unlicensed. Google won't control a service. The community will. What service do we envision? And my favorite line is, we envision services that we can't envision today. No one could envision Wi-Fi when 2.4 was allocated. And the same thing we see here is once this low-frequency unlicensed spectrum happens, there's going to be services that we can't envision today, and that's the real value. We think there might be some Wi-Fi 2.0, wider range, Wi-Fi-ish broadband, but again, we can't really say. So the bottom line on Whitespaces here is after years, as Michael talked of analysis, the time is now. The OAT has issued a report, the OET, the Office of Engineering and Technology, saying that it is the right thing to do to make this unlicensed, personal portable. So the engineers have spoken, and for years the Commission has said we're going to defer to the engineers on this. Well, the engineers have now spoken and endorsed this concept. The FCC is set to vote. No one should be under any illusions that there's not going to be a last-minute play, a political play, not an engineering play, a political play to stop this. So if you're in a position to support this, the time is now. November 4th is a big day where we'll hopefully get this spectrum allocated for unlicensed use. So just to mention what else Google is doing in this kind of access and spectrum related, we've heard about Android. And the important thing is Android's not just a G phone. Android is an open development platform that will hopefully be taken into lots of different devices on lots of different networks, and maybe even some devices that don't attach to the big cellular networks. The idea is to promote innovation. Just like in the web, the standards of HTML and JavaScript have allowed people to write applications widely. We believe the standard platform of Android will also allow that to happen. We've taken an investment in Clearwire, which really is a company that's trying to provide a high-capacity, open wireless network. They've got a lot of challenges that lay ahead, but they have a lot of spectrum at their disposal and are heading in the right direction. We've invested in companies that try and extend the wired broadband. These are companies like Meraki and Ubiquisys that take the wired signal and just try and expand it in the local area to provide a rich connection. And we've also looked a little bit in terms of access at developing countries, bringing their first access through satellite broadband, and we've invested in an initiative called O3B. So the point here is we're doing a number of things, trying to promote open access and bring access to people. And with that, that's it. Thank you.
All right, thanks, Larry. I envy how remarkably clear he is on all these points. This is great. So we have just maybe time for a couple questions. I don't want to get us too far behind, so that people can have time for lunch when this is all over. But I guess you use the microphone. Let us know who you are, and we'll try to be.
Sure. My name is Rohini Chakravarti. I'm at the venture firm called NEA. So the question I have is around business models. So with these open networks, it's yet to be proven that you can actually have a business model that's around truly unlicensed and truly open networks. So either the government provides it, or there is a private enterprise that's, making money and providing this service. How do you see those things coming together in a truly open network?
I'm glad you asked that, and in fact, that's going to be the topic of my next presentation, and I'll give you a number of examples to demonstrate that an open, sustainable model is, in fact, not only possible, but has been deployed for years already in multiple different locations around the globe. We just don't hear about it in the States. We don't have PR firms and marketing campaigns for open source solutions, but they're there.
Okay. Can you give us a preview?
I'd like to take a stab at that question. You know, I mean, you might have asked the same about the internet itself.
Yeah.
You'd say, you know, you got this non-commercial network created by a bunch of strange government scientists. There's no way this is ever going to support any business model. I mean, give me a break, right? I mean, it's ridiculous. And you know, most of the businesses don't own any of their underlying connections. So no, there's no way you could ever build a company on that kind of network. Well, I think we're sitting in a company that was built on that kind of network, so it's kind of proofs in the pudding, isn't it?
Which owns a lot of its underlying connections now.
Yeah.
Some of them, but I'm just saying, like, probably 20 years ago, you would say there's no way you could have a business that can run a business model that doesn't own the underlying connections.
No, and I think there are companies that make money on the pipes as well, right? So, I mean, DSL and cable companies do make money on their internet pipes, and there has been a separation of the application layer versus, you know, the dumb pipe layer, right? The question is whether it's a purely business model related thing or is it a fundamental architectural thing that's necessary, right? You have cellular networks today where that separation has happened in other countries. And you mentioned China. If you go to India, you can actually buy cell phones and get on the cellular network, and that business model stuff can happen independent of the openness or closedness of the proprietary technology that you have.
Yeah, I'd make the comment that one of the things I see happening in the future is this idea of a single network serving you. Instead, there'll be multiple networks that serve you.
Right.
You'll attach to corporate networks through like unlicensed, and that will change the business models from this one centralized, I'm going to control you wherever you are, to devices that attach to multiple networks to get the best possible connection anytime. I think that'll change things.
Yeah, in fact, that's one thing that ties together the previous panel and this one to some degree, which is what dynamic spectrum, this idea of a device, right, that can hop among frequencies depending on what's available to you. What that allows is exactly what Larry said, which is part of our vision as well, this notion that you can be carrying a device. There may be times you want to pay AT&T for quality of service, or where you're out in some remote area where their cell tower is the only thing reaching you. But you also want, and this is what, when Tim Wu talks about them stripping off Wi-Fi and so on, what you also want is when you're in a place like Google, it would be crazy to be paying AT&T for bandwidth when you're close to a wire that you should be able to get on, or a Wi-Fi network or some cheaper WiMAX. So you should be able to your device should be able to automatically scan around and see what is the best connection, the most cost-effective connection for you at any time given your purpose.
Hi, Steve O'Kay with Invenio. We're a social enterprise up in San Francisco. I do a lot of work with community wireless networks, particularly in technology for sustainable communications technology for the developing world. I've been in Africa, and I've seen just how rampant the use of cell phones is over there, and the application deployment over there, how there is an entire economy based on sending cell minutes around to individual users to make payments for services, to buy applications you can download onto the phone and run things like that. I'm much more skeptical about applications on phones here, and I'm looking for maybe some hints or details on how you think this is actually going to work here in the U.S. with things like with Android. We've already been through a couple rounds on early PDAs, early cell phones, where there are great, like the Sidekick, for example, great development platform that was promised, and T-Mobile just put their foot down and it dragged it out and never happened. I know some people who actually ran the developer program quit and came to work here at Google. What is to say that Android is going to be any different since, again, their only provider is T-Mobile?
I'll try to field that one, but first I'll say I'm not on the Android team here, so I'm probably not going to give you the most insightful answer.
Yeah, It's more of a general question because it seems to be more of a policy or a organizational corporate kind of attitude than any particular platform or technology.
And I think the strategy of Android is pretty clear. The idea of making it an open source platform so people can put it on a variety of devices, both devices that attach to cellular networks and other networks. It's the idea of this open source is the key here to let multiple devices. Now there's a challenge of scale, and hopefully Google and the other members of the Open Handset Alliance can help bring that scale to the industry, because once the scale is there, then the developers will come and the devices will be used. And one of my things I hope is that people don't view this first device, the G phone, as the product. The product is the open source operating system, and we're going to have to see several devices to get out there and see that scale really build up.
Yeah, I agree with the questioner. I think it is a challenge. I think that the problem is that the problem is that the carriers have the idea if it doesn't pay, it doesn't play. So in other words, they consistently want to know if I let this application. They have this sort of thinking: if I let this application on my network, how do I make more money? And if it doesn't obviously generate a new stream of revenue for me, forget it. That's the traditional way of thinking. That's the Bell system original way of thinking, and it's still very powerful. Has a lot of hold on the industry, and you can sort of see why. Although I think sometimes it can kind of be self-defeating, and that the platform would become more valuable if they let more stuff onto it sometimes. And I think it's slowly changing, but I agree with the questioner, it's a challenge.
Okay, so what I'd like to do is have you these last two here. Each of you give your question, and then we'll go right down the line as far as whoever is the appropriate person to comment. So then we can move on to our third panel. So go ahead.
Ralph Mueller, Internet Archive. If you look at the current use of unlicensed spectrum, like the 2.4 gigahertz band, there's a lot of interference from devices, and they're all doing the same thing. They're all trying to get on the internet. What do you think of a proposal to require all whitespace devices to forward packets to neighboring whitespace devices? So kind of built-in peering in the regulation.
Okay, and the other one?
Hi, it's Luca Rigazio, Panasonic R&D. So it's an interesting discussion. I feel like there is a keyword that was almost missing from today's discussion. I said almost, and that's WiMAX. So I like to try to. You talked about Clearwire and the investment. So I'm trying to see how you see WiMAX tying into the discussion, because it should be tying. That we had today, and how do you see that effort? Moving forward. So thank you.
Who wants to go into this?
The first question is your session.
Okay. Yeah, I'm a big proponent of the ad hoc networking philosophy and the scalability and efficiencies that come when you have devices infrastructure networking. You asked about doing this. I think it's a good idea. Requiring it, I think, might be a bad idea, just because technologically speaking, wireless of all sorts is in its infancy, and I really don't know what 5 or 10 years from now it's going to look like. But these sorts of ideas, I really wish we were, in fact, more innovative in what we're trying out or allowing us to try out. One of the biggest problems has just been getting access to the sandbox so that we can test out new algorithms and scaled systems for how to make more efficient use of spectrum. And obviously, whitespace is, in some ways, also fantastically useful for piloting out these next generations of devices and protocols and routing algorithms.
I'll talk a little about to the WiMAX question. To the WiMAX question, WiMAX is very interesting because it's not coming out of the telco world. It's coming a little bit out of the computer side of the world. That makes it a little different and a little interesting. It's unclear exactly what kind of market share we'll ultimately have, but we are seeing now as WiMAX devices are starting to be built. If you go back to the shared spectrum guide, they've got a chip in there. They said that's a WiMAX. So all of a sudden, the economies of scale that we saw in Wi-Fi chips are not there yet, but the early WiMAX chips are starting to be there, and people are starting to use them in different and unexpected ways. And I think that's one of the unique things of WiMAX. And then, of course, there'll be the traditional carrier type of deployment for wireless broadband with WiMAX, but I believe there'll be alternatives.
Anything, Tim? Or? Okay. All right, well, thank you for this great panel on open networks. And